So in this video, we're going to do an introduction to functions and graphing. So let's hop right in. So I'm sure you've seen this picture before. This is called a Cartesian plane. Now, essentially, the y-axis is vertical and the x-axis is horizontal. So if we have a table of x and y values such as this, all we have to do to graph this on the Cartesian plane is just count the spaces on the x and y axis and plot each point. So the first point, -2 and 4, in order to plot that we need to move to -2 on the x-axis and +4 on the y-axis. So this point right here will be -2 and 4. And let's say we want to graph the point 1, 1. All we have to do is just move across 1 on the x-axis and up 1 on the y-axis. So this is pretty straightforward, so I just filled in the rest of the points. But what if we were given some sort of equation that relates the x values on the table to the y values on the table, instead of just giving us the x values and the y values directly? This is called a function. So essentially, a function takes a certain value of x and turns that value into a certain value of y. Now, in a function, usually x is known as the independent variable, and that's because we choose the value of x. X can be any value, but y depends on x, so y is called the independent variable. Now, you might have heard of something called a relation before, and this is the difference between a function and a relation. A relation is simply the relationship between x and y values, but a function is a specific type of relation where each x value has a distinct y value. Now, this is why if you draw a vertical line on a Cartesian plane, it will never intersect 2 points on a function. So in the first example that we did, this is actually a function because if we draw a vertical line on the Cartesian plane and inspect it anywhere on the function, notice how the vertical line will only ever intersect 1 point. Now you can easily tell if something is a function or not if you just do this test. It's called the vertical line test, and all you have to do is just see if it ever intersects 2 points on the function. So just like in the example above, this orange line right here is definitely a function because the vertical line only ever intersects 1 point on the function. On the other hand, this relation in blue is not a function because the vertical line intersects 2 points, which means that a certain value of x gives you more than one value of y, so it's not a function. So now let's talk about the equation y equals 2x plus 1. Now, this is probably how you're used to seeing an equation, and you can graph that equation, and we know it'll be a straight line because the degree of the independent variable x is 1. Now, looking at this equation, we can tell that this is a straight line with a slope of 2 and a y-intercept of 1. Now, if you don't know how to find this, you can watch my other video on slope, but that's not what we're talking about here. So like we talked about before, the independent variable in this equation is x, and the dependent variable is y. And that's because we can choose any value of x, and we will get a certain value of y. So even though you're used to seeing the equation of a straight line in this form, y equals 2x plus 1, the proper way to write a function is like this. This symbol right here, this f and this x, just means f of x, where f is the name of the function and x is the independent variable. You'll most commonly see functions written using the name f and the independent variable x. However, you can use any variable and name such as g of x or h of x. Those are some other common ones that you'll see, but usually f of x is used. Now, the value of f of x is the dependent variable. And this is because we choose the value of x, and it gives us the value f of x. So let's say we want to graph the function f of x equals 2x plus 1. We can start out by making a table of x and y values. Now, instead of y values, we can actually just say f of x values. Now, the first thing that we want to do is just choose some random values of x to graph. So since we want to make this graph on this page, we'll just use some small values. We'll start at -2 and go up to 2. Now, in order to find the y values on the graph, we can plug in the x values, the independent variable, into the function, and it will give us the values of y that we need to graph the function. So let's start out with -2. The proper way to write it out is f of -2 equals 2 -2 plus 1. Now notice how, since the independent variable x takes the value of -2, we simply substitute it into the function here and here. Because if you notice, there's an x right here and an x right here. So the y value of the function when x equals -2 just equals 2 times -2 plus 1, which is -3. So when x equals 0, we know that f of 0 equals 2 times 0 plus 1. And this simply equals 1. So that means that when x equals 0 on the function, y will equal 1. So let's try one more. What if we wanted to know the value of the function when x equals 2? All we have to do is plug in 2 into the function. So we know that f of 2 equals 2 times 2 plus 1, which equals 5. Now we can quickly do this for the rest of the missing values. And there we have it. So now that we have the values of x and y for a couple of data points, we can graph the function. So to save some time, I took the points that we just figured out using the function and the independent variable x, and I graphed it on a Cartesian plane. Now, since it's a function, we can join all of the points together, and no matter what the value of x is, the line will continue to be straight. This is because this function is called a linear function. When your independent variable has a degree of 1. So what this means is that since the x attached to 2x has an exponent of 1, the function is linear. But if it had, for example, if we had 2x squared or 2x cubed, this function would not be linear. It wouldn't be a straight line. So overall, the most important thing to understand about functions is how they take an independent variable x and they turn that number into a dependent variable y, which you can then plot on a Cartesian plane. In the next video, we'll be able to figure out the function of a line just by looking at it on a Cartesian plane and seeing where the points are, but that's a bit more complicated, so we'll save that until next video.